All right. Well, I suppose we should get this started here. So, I don't have a whole lot going on with pull requests that I remember seeing. It's been a little bit slow in the last couple of weeks, but there were two updates that I saw. The first one is from Igor, this get rid of StatFS update on each transaction. Adam reviewed it and approved it, and Igor's got a couple of additional updates there. So I think it probably just needs another review from core, but otherwise, sounds like it's moving along and probably looks pretty good overall. The other update was adding Codel to Bluestore for buffer bloat mitigation. And Sam did get a chance in the past week to review that and has a number of changes that he requested. So it looks like that's not quite ready yet, but is actively in the works, actively being reviewed. So that's good. That was it. That was all I really saw for updates this week. Was there anything from anyone that I missed? All right. Well, then, moving on to discussion topics. We did just kind of talk about this RocksDB tuning. I've got an article, basically a blog post in the works that's turning out to be quite long. But the good news is that for the last year or two, there's been kind of these RocksDB tunings that have been floating around on the mailing list and on blog posts, where the number of in-memory buffers for the write-ahead log is dramatically increased, and the size of those buffers is reduced, while simultaneously allowing you to accumulate two of them into a flush to the database. And I've been a little wary of that tuning, primarily because some of the options that were changed regarding the number of threads for compaction and the number of threads for flushing were ridiculously high. And I kind of wasn't convinced that this tuning made a whole lot of sense. But in the past couple of weeks, I've tested it, and it actually results in fairly decent behavior. And in fact, we don't see the write amplification increase with it that we typically see when using smaller mem tables and smaller flushes overall. And it turns out that primarily that's due to changes that were made in the number of files that are allowed to accumulate in level 0 and the size of L1. Generally, you want those to be matched. So the good news here is it actually works better than I expected it to, and I'll say as much in this article. But the even better news is that we can do actually better than that by also tweaking level 0 and level 1 and having even more smaller buffers that are accumulated into a larger flush. We can actually get even better RBD performance and not have a huge increase, a fairly modest increase in write amplification database. It's basically like over our stock settings, a 20% performance gain on our faster NVMe systems for like a maybe 10% write amplification increase. So it's actually not even that. It's 10% writes to the database increase. So in reality, it actually might be lower write amplification, but it's roughly the same. And the key there is this level 0 and level 1 tuning. So I'll talk about that in the article, but the gist of it is that it looks like we can do significantly better than the current Bluestore defaults, and we can do better than this alternate tuning as well, so long as we're really careful about the tweaks that we make. So I'll have that coming out at some point here, but just wanted to let people know it's in the works. The other thing I'm working on is looking at our sharding and threading behavior in the classic OSD, and there's some evidence that that when we allow OSD shards to become empty, our efficiency goes down significantly due to the way that we call notify all for all threads to wake up. And that's we've got data for it, but that's farther behind. That will more of that analysis and work will happen after this other article is done. I may try to change the way that we wake up threads in the OSD as well. So anyway, that's in the works. So that's basically all I had. Any question on either of those things, or any questions? If not, then I'll open it up to everyone else. Is there anything folks would like to discuss this week? Gabby, I'm going to pick on you a little bit because I know you've been working hard on the Snap Mapper and have done some work there. Anything interesting to report yet?
So I'm working on it. I'm rewriting the whole code. I finally understood what happens in the snap mapper. It took me some time and help from Josh and running with debugger to realize what the data structures are doing and why. So at first I tried to give Paul Kusner a version just skipping RocksDB update. Apparently when this thing is done, when you try to trim, you don't have copy of the data. So my understanding so far was that RocksDB is only used to store long-term copy and the rest is in memory, but apparently it's not the case. It seems that it's really that we read it from RocksDB. So I'm now working on a new version when everything is stored in memory, and today I finished just writing it and now I'm trying to debug it, and of course nothing is working, but that's expected. This weekend I'm flying to Rome, so I'm only going to be back Monday. So only Tuesday I'm going to be working back on this. But I hope to get some improvement on this.
Gabby, when on the new version you're working on, will there be any? Will it be per PG? Will we be able to?
Sorry, the current version is already per PG. There's something we didn't understand because the key has the PG, the pool number, as part of the key. So we assume it's a data structures where you keep multiple PGs inside, but I really don't know why we keep the PG number as part of the key. But the data structure is kept per PG. But one thing we do optimize is that now we break it by snap ID. The existing data structures, say you have 4 active snaps, then all of them reside in a single red-black tree. We're now going to use a single repository for every snap ID. So it's going to be snap ID and PG, which determine what repository to use, and only then you go and use it. And we also change from trees to hash tables, and from strings to using snap IDs and H object as the data structures that we maintain. So they're going to be no translation, no toString and from string, no encoding, decoding. Everything is just as is. And
that sounds fantastic.
Be a bit smaller.
That sounds great, Gabby.
Yeah. So I expect that we will save a lot of memory, but it depends how many objects really exist in the system. I don't know that number. If the number of clone object is small, then whatever we do is not going to make much difference on memory footprint. If we have many of them, then sure, that's
cool. All right, well, enjoy Rome, and definitely will be be excited to hear more about your work on this later on.
Yeah, so it's still a work in progress. I was getting some help from Ronen today and yesterday, and trying to do all the C++ optimization, and there's going to be probably another iteration of C++ layout and structuring. Hopefully, I'm going to be able to get hold of him next week as well, and then I hope to get everything working. Shouldn't be too long. I mean, just to be able to test. It's still not going to be data structures which you could use because they're not persistent. But once this thing is done, I expect that reconstructing from the object node should not be a very long project to do. Probably a couple of weeks.
Okay, cool. All right. Well, I don't think I have anything else, guys. So unless anyone has something they want to bring up, we'll wrap up early today. All right. Well, thanks for coming, everybody, and we'll talk again next week. Have a great day.